Okay, we are beginning this lecture. Now we are going to discuss today the applications of the Lagrange interpolation method or formula. We have so far seen Lagrange direct method of interpolation as well as Lagrange inverse interpolation method. In both of cases, we have seen some special advantages which were not given as a facility in previous cases. In this problem, we are going to discuss the estimation of the value of the function for the given value of the arguments, number one. But there was one assumption laid down in other previous methods that the arguments were equally spaced. Now in the Lagrange method, arguments are not equally spaced. So first advantage is that the arguments are not equally spaced. Second advantage of the Lagrange method is that the process of computation can be reversed. Process of computation can be reversed. It means, I mean to say that for given value of the arguments, we were able to compute the value of the function, but whenever we are going to reverse the process of computation, it means that for given value of the function, we can compute the value of the arguments. This facility is special for us. So here we are going to discuss today two very important numericals which are seen here. These numericals are, you look at this screen is seen screen.
Yes, sir.
Yes, sir.
Okay. There was who is speaking this way. And so there was some problem in the internet connection. Therefore, the lecture was obstructed. Now we have started again. There was some really problem. Now, so we concentrate on these numericals. The first numerical is related to Lagrange interpolation method, and the second method is related to inverse Lagrange interpolation method. In this way, both will be clear as a concept. So look at here, the following data set is given. We have already explained the x is given 5, 6, 9, 11, and y is given 3, 8, 0, minus 2, 1, 9, 6, 5, 0, 8. The question is find the value of y corresponding to value of x is equal to 10 using Lagrange interpolation formula. So here Lagrange has the facility as comprised of one special facility, that is arguments are unequally spaced. Arguments are unequally spaced means you look here 5, 6. Space is 1, 6 and 9 space is 3, and 9 and 11 space is 2. So in this way, here unequally spaced. The formula is what? There is no requirement of beginning and ending data set while applying this method. If you remember the Newton's forward interpolation as well as Newton's backward interpolation methods, we had to see the location of the data corresponding to which we are going to compute the value of the function, whether it is located to beginning or the end. So here there is no problem to judge the situation as we discussed the beginning and ending. So we directly write the formula. Formula used in this problem is, as usual, I told you, x naught minus, here is y naught. To remember this formula, I am telling you the rhythmic position to remember, to keep in mind x naught. So y naught, x naught minus x1, x naught minus x2, x naught minus x. So x naught is taken here, then x1, x2, x3, and x naught is taken here. So x naught would not be considered here. Means x, this is the argument. So x1 value, x2 value, and x3 value. So whatever it is taken here in the denominator, and here y naught corresponding to x naught, x naught is left here. Second part of the formula, the y1, then y1 means x1 is here, x1 minus x naught, then x2, leave the x1, otherwise this will be 0, x1 minus x2. Here is x1, so x1 is left out, means x minus x naught and x minus x2, and x minus x1 is left, and x minus x3. Similarly, this is the y2, y2 is here, then x2 minus x naught, x2 minus x1, x2 minus x3, and x2 is left here, so x naught is here, x1 is here, and directly then x3. Similarly, the y3 means x3, x3 is here, x3 is here, x3 is here. It means that x naught, x1, x2 is here. And then x3 will be overlooked, means x minus x naught, x minus x1, x minus x. So this is the formula. How we can remember the formula? It is a rhythmic or some way out to remember the formula, so that we cannot forget the formula at the time of examination or test. So here is, according to this formula, what we are given, x naught to x3 is given, y naught to y3 is given, and x is equal to 10, for which we are going to compute the value of function. Okay. X is equal to, for x is equal to 10. So here everywhere you will find x means 10, 10, 10, 10, 10, and it is y naught, it is the y1, it is the y2, it is the y3. So how long will you write the terms? As many as the functions we have, so we started the functions. Values of function is what? Y naught, y1, y2, y3. So this is the y3. If you look at the formula is over at y3. Y3 is where? Y3 is this. This is y naught, this is y1, this is y2, and this is y. So up to y3, this formula will continue. Thereafter, their terms will not exist or will not come out. So, okay, we substitute the value of this one, value of -2, value of 196, and the answer is 330. So here the value of the function, what we were expected, here corresponding to this is the 330. This is the 330. This value is 330. So it is very simple, I think. Now come to the second example, the inverse interpolation. Look at this formula, look at this problem. The following data set is given as, this is x is equal to 1, it is 2, it is 5, it is 7. Another verification we can make, here 1 gap is 1 and the gap is 3 and the gap is 2. So it is also unequally spaced interval. So y is given 1, 12, 117, 317. So this is y naught. So we started from y naught, and this is y naught, y1, y2, y3. So the formula will have how many terms? 1, 2, 3, 4 terms. Means 0 to 3. The value of x for corresponding value of y is 167.5979789 by applying Lagrange inverse interpolation formula. Lagrange inverse interpolation formula. This method of Lagrange inverse interpolation formula has a special advantage of inversing the process of computation. As we have already discussed, the value of the argument corresponding to the value of y can be computed. Earlier, this facility was not available with any method. So this is a very special advantage of which this method is embedded on. Okay, look here the formula. Inverse interpolation or Lagrange inverse interpolation formula. The only difference is that here it was y naught, here it has become x naught, it was y, it has become x, it was x naught, here the y naught. So formula is simply interchanged. So once you remember the formula of the Lagrange interpolation method, you can easily remember this formula. Nothing to do, simply just write that formula and keep the Lagrange interpolation formula in front of you, before you, and keep on interchanging. Instead of remembering this formula, do not remember this formula, only you memorize single formula and just you repeat this one by interchanging. You will get this formula. So there are 4 terms here also, 1, 2, 3, 4, x naught, x1, x2 and x3. Given that x1, x naught is 1 and x1 is 2, x2 is 5, x3 is 7, y naught is 1, y1 is 2, y2 is 117, y3 is 317. Y is equal to 167.5978, for which we are corresponding to this value, we want to the value of x here. It is our purpose of applying this formula. So what we are going to do, we are going to substitute these values. So this is the y, given y, so everywhere you will find y, everywhere you will find y. This is the y naught, so it is y1, this is y2, this is y2, and this is the y1, so this is the y naught, this is the y2, and this is the y. Y value is everywhere, fix everywhere, y, y, y. So when we substitute this value and we simplify, we get the value of the x 5.65238, 5.65, 5.65. You look here, 5.65, 5.65. What was the 167 somewhere? Y was 167. 167 approximately 167. So 167, Y is where? Somewhere here you can say 167 in between this two. Y67 corresponding to value of this. We have got here 5 point something. 5 point how much? 565. 5.65. You look here. 5.65. 5.65. 5.65. So 167 point something. This is the value. So in this way we can compute the value of x and y both, and this Lagrange interpolation formula, inverse as well as direct, both are very useful, and that can be applied when intervals are not equally spaced. In this way